Hi guys, welcome to the next section, Detecting Patterns with Unsupervised Learning. We will start off this section by learning about unsupervised learning. Then we will be clustering data with k-means algorithm and estimating the number of clusters and the quality. Proceeding further, we will learn about Gaussian mixture models. Then we will be building a classifier and finding subgroups in stock market. Finally, we will be segmenting the market based on shopping patterns. Now we move on to the first video of this section, clustering data with k-means algorithm. In this video, we will first learn about supervised learning and then we will be clustering data with k-means algorithm. Before we begin with clustering, we will learn about unsupervised learning. Unsupervised learning refers to the process of building machine learning models without using labeled training data. Unsupervised learning finds applications in diverse fields of study, including market segmentation, stock markets, and so on. When we have labeled training data, the algorithms learn to classify data based on those labels. In the real world, we might not always have access to labeled data. Sometimes we just have a lot of data and we need to categorize it in some way. This is where unsupervised learning comes into picture. Unsupervised learning algorithms attempt to build learning models that can find subgroups within the given dataset using some similarity metric. Let's see how we formulate the learning problem in unsupervised learning. When we have a dataset without any labels, we assume that the data is generated because of latent variables that govern the distribution in some way. The process of learning can then proceed in a hierarchical manner, starting from the individual data points. We can build deeper levels of representation for the data. We now move to clustering. Clustering is one of the most popular unsupervised learning techniques. This technique is used to analyze data and find clusters within that data. In order to find these clusters, we use some kind of similarity measure, such as Euclidean distance, to find the subgroups. This similarity measure can estimate the tightness of a cluster. We can say that clustering is the process of organizing our data into subgroups whose elements are similar to each other. K-means algorithm is a well-known algorithm for clustering data. In order to use this algorithm, we need to assume that the number of clusters is known beforehand. We then segment data into k subgroups using various data attributes. We start by fixing the number of clusters and classify our data based on that. The central idea here is that we need to update the locations of these k centroids with each iteration. We continue iterating until we have placed the centroids at their optimal locations. We can see that the initial placement of centroids plays an important role in the algorithm. These centroids should be placed in a clever manner, because this directly impacts the results. A good strategy is to place them as far away from each other as possible. The basic k-means algorithm places these centroids randomly, where k-means chooses these points algorithmically from the input list of data points. It tries to place the initial centroids far from each other so that it converges quickly. We then go through our training dataset and assign each data point to the closest centroid. Let's apply k-means clustering on two-dimensional data to see how it works. We will be using the data in the data_clustering.txt file provided to you. Each line contains two comma-separated numbers. We have first created a new Python file and imported these packages. Next, we have loaded the input data from the file. We need to define the number of clusters before we can apply k-means algorithm. We have defined it as 5. We need to visualize the input data to see what the spread looks like. Then we have created the k-means object using the initialization parameters. The init parameter represents the method of initialization to select the initial centers of clusters. Instead of selecting them randomly, we use k-means ++ to select these centers in a smarter way. This ensures that the algorithm converges quickly. The nClusters parameter refers to the number of clusters. The ninit parameter refers to the number of times the algorithm should run before deciding upon the best outcome. We then train the k-means model with the input data. To visualize the boundaries, we have created a grid of points and evaluate the model on all those points. Let's define the step size of this grid. We then define the grid of points and ensure that we are covering all the values in our input data. Moving ahead, we predict the outputs for all the points on the grid using the trained k-means model. This code is used to plot all output values and colour each region. This part of code overlays input data points on top of these coloured regions. To plot the centres of the clusters obtained using the k-means algorithm, we use this part of code. Let's run the code. We get two plots. The plot is the input data. The second plot represents the boundaries obtained using k-means. The black filled circle at the centre of each cluster represents the centroid of that cluster. So, we have clustered data with the help of k-means algorithm,